What is 9 plus 10? 21. The boy from this vine isn't wrong. If we look at the numbers in base 9, not 10, the answer is truly 21. The amount never changes, but how we look at the numbers does, which results in a different value. When we normally use graphs, we use the Cartesian coordinate system, which has two defining characteristics: two perpendicular lines, our x and y axes, and a specific length to be defined a unit, which is normally just 1 and the same on both sides. This is my doggo Leo. He is sitting at the point 5, 3. But if I shift the axes, he ends up at a different point, 1, 1. His location doesn't change, but the value we assigned to his location does. It's like having the same point, but using skewed graph paper instead of regular graph paper. For more complex mathematics, rather than a point, it is more useful to use a vector. A vector is the line taken to get to a point, with magnitude and direction. When using the Cartesian coordinate system, we can find a vector using the standard coordinate vectors, 1, 0, which represents moving along the x-axis, and 0, 1, which represents moving along the y-axis. This is called a basis, a group of vectors which provide a lens through which we look at our graph. Each component of our final vector is called a weight, and tells us how many of each basis vector to add to get to our final vector. This is the formula to calculate the standard coordinates of a vector in another basis. Though this formula can accommodate for as many dimensions as necessary, we can stick to 2 dimensions, which is the easiest to visualize with a graph. For example, if we have the vector 2, 1, that means we move 2 times 1, 0 and 1 times 0, 1. Going back to Leo, we can see his position using this formula. In this basis, his position is -1, 2, but using the formula, we can calculate what this would be in the standard coordinates, 1, 3. More formally, a basis is a matrix, with the columns representing each vector of the basis and the rows representing the dimensions. The applications of matrices are numerous, as math is the basis for all forms of science. Change of basis is used to simplify a complicated matrix, which helps with diagonalization. It is a seemingly simple process, but opens up the wide array of possibilities of using linear algebra habitually, like for... Pause the video for a summary, and thank you for watching.